Good morning, dear students. Today we will discuss about simple pendulum. The pendulum you may have seen in some old clock, isn't it? In household clock. So pendulum is related to time. It means it is an instrument to measure a time period or simply time. But what about simple? It means a pendulum that can be prepared or made in a very simplest way or manner. Clear? So what is that simple manner? If we take a cotton thread, a thread or string of certain length. Generally, the thread we use in our household for sewing clothes. So that string, and if one end of the string is attached to one hook of a rigid support, and to the other end, if we suspend a heavy spherical metal ball, which is called bob, then this arrangement is generally called a simple pendulum. Through the oscillation, we can find out the time period. Okay, and the most important fact is that through the simple pendulum we can calculate the acceleration due to gravity of that particular place. Clear? So how? Let's see. So first of all, we will just try to understand some important topic related to simple pendulum. So first, the basic thing which is associated to simple pendulum is oscillation. This is the vital oscillation. Without oscillation, nothing is impossible. Clear? So what is oscillation? Oscillation is just swing, or we can say the to and fro motion of any object is called oscillation. So what is to and fro motion? Motion towards left or right or up and down, which is called to and fro motion. So here we have prepared a simple pendulum. You can see this is the one end of the string fixed with a hook of rigid support and the other end a metallic bob. So now if we displace, when the simple pendulum was at rest, absolutely rest, that is at equilibrium, if we displace it towards left or right side, so this is called oscillation. Clear? But this is not the complete oscillation. What is the complete oscillation? If we displace the bob towards the left side, then if we release it, then from it will just move towards this position, it will just try to oscillate like this. Clear? So from B to C, then again when it will return back to its initial position, it is called one complete oscillation. Or if we displace it toward the right side initially, then from A to C, then if we release, then after that it will just oscillate to A, B and then B, A to C. This is one complete oscillation. Or from A to B to C to A, or from here A, C, B, then A. All these are called one complete oscillation. Clear? Here it is mentioned, you can see. Now effective length. Here effective length doesn't mean only the length of the thread or string. It means from the fixed point of the rigid support up to the center of the bob, metallic bob. It means the length of the string plus the radius of the bob, called effective length. Generally we can measure the radius of the metallic bob by using slide calipers. We have already learned. Clear? That is OA, you can see. Clear? OA up to. Now amplitude. Amplitude is the maximum distance of any particle or any body from its mean position, if it displays towards the left side or right or up or down. Maximum distance. Clear? So if we displace the bob from position A towards the left side, then it will just cover a maximum distance, then it will return back. So this distance AB is called amplitude, or towards the right side AC, this is called amplitude. Clear? Moves on to time period. Time period, you can see it is related to time. It measures only time. Time period means the required time to complete one oscillation. Clear? That is from B to C, then again to return back to B. Then the time which is taken by the pendulum, it is called time period. Or from C, if we displace up to C, then if we release it, then from C to B, then when it will return back to C, then the required time is called time period. If it takes 10 seconds, time period is 10 seconds. If it is 15, then 15, 20 and so on. Clear? Frequency. What is frequency? Frequency is just a reciprocal of time period. How? That is the number of oscillation in 1 second. What is that? Now suppose for 20 seconds, okay, for 20 seconds it completes in In 20 seconds it completes 20 oscillations. So in 1 second how many oscillations? Only one oscillation. Clear? Time period is suppose, okay, here 20 oscillations for 40 seconds. So in 40 seconds it will complete 20 oscillations. In 1 second it will be 20 by 40. Clear? So time period means the total time for completion of one oscillation, whereas frequency means the number of oscillations in 1 second. So that's why frequency and time period are okay. Now here 20 seconds, this is time period, and 20 oscillations. Clear? This is time period, and one oscillation for one oscillation. Clear? So we can write T equals to 1 by F, or F is equal to 1 by T. Clear? Now here you can see in 20 oscillations, okay, it is 40 seconds. Now in one oscillation it is 20 seconds. So what is that? So we can say it is time period, because time period is the required time to complete one oscillation. Now if we want to discuss about the frequency, just opposite. What is that? That is in 40, okay, in 40 seconds we can complete 20 oscillations. So in 1 second, that is 20 by 40, that is half. So isn't it reciprocal? Time period was 2 seconds, whereas frequency was half. So it is reciprocal. So that is the relation between time period and frequency is just reciprocal. Clear? So this is time period and frequency. So now the clear. Now the factors affecting the time period of simple pendulum, for that I have already prepared a video, you can see in YouTube. Okay. So now how to find out the time period of a simple pendulum? The simple equation, that is T equals to twice pi into by L by G. Clear? So from that T square is equal to 4 pi square L by G. So G is equal to 4 pi square L by T square. So how to find out the acceleration due to gravity from that? For that we will take different effective length of the spring. Clear? It means we will take a long thread and we will just increase or decrease, okay, the length of the string. We will just manage either in the ascending order or in the descending order. So here we have taken in the descending order. At first the length of the string we have taken with 100, then 90, then 80, then 70, then 60 and 50 centimeter. For each effective length we will just calculate the required time for 20 oscillations for each. When the effective length of the string is 100 centimeter, we will just take required time for 20 oscillations. Clear? Then how we will find the time period? Dividing it by 20. Dividing it by 20 we will get the time period, and the required time divided by total oscillation. Suppose, clear, for 60, okay, for 20 oscillations. For 20 oscillations here it is 60 seconds. So for one oscillation it will be 3 seconds. In the same way we will just reduce its length by 10 meter, 10 centimeter, then we will make it 90. Then it is called, then we will again take the required time for 20 oscillations. We will not decrease or increase the number of oscillations. Number of oscillations is same. Since the length is varying, so that's why time is varying. Clear? So let it be 50. Then as we decreasing the effective length, time is decreasing. Why? Because the time, okay, the effective length, the time period is generally, but the time is generally decreases. Since the effective length is going to decrease, the effective length is going to decrease, so that's why the time period is also decreasing. As you can see, T equals to 2 pi root over L by G. Time period is directly proportional to square root of the length. So as length decreases, so that's why required time also decreases. It has been described in my second video. So from that we will take the value of T. So T will also be in the descending order. From that we can get the value of L by T square, dividing length divided by T square. Clear? Then putting this value here, we will get the value of acceleration due to gravity, which will be very equal to 9.8 meter per second. It may be 9.79, 9.77 or 9.9. Okay, it varies, very small. Okay. So this is the simple pendulum. Okay, and there is another pendulum which is called compound pendulum, which is generally used in our hub which were generally we have seen in the ancient days, okay, in our grandfather or grandmother house, isn't it? That is we used to, that is a simple pendulum, not a compound pendulum having a long metal handle with a circular disc made up of stainless steel or any metal. It is not a bob, it is a flat, okay, a flat circular disc, dhong dhong, okay, the bell rang generally in this way, okay. So this is compound pendulum, okay, and this is simple pendulum. Simple pendulum can be prepared only by a string and a metal bob. Whereas the compound pendulum, the one characteristic is that due to season change, it generally becomes faster and slower. Why? Because since its effective length or the handle is made up of metal, so during summer it's generally expanding length, and since length is increased, so time period, okay, time period also increases. It means it delays to complete one oscillation, so it becomes slow. Clear? And during winter its effective length contracts, since it is of metal, so due to heat, contraction of, okay, because of heat, expanding length, and because of reduction in heat, it contracts, so it oscillates fast, okay, and this time period is less and it generally runs faster. Clear? Now one thing that I told, that the string has to be massless and inextensible. Why? Now if the string have sufficient mass, then it would affect in its time period. You can see. So if it is massless, then it's one authentic time period, and if you take a rope, its time period will change. So the acceleration due to gravity will also change of that place. Effective length, if the effective, okay, and if it is inextensible, why is it taken inextensible, not extensible? Extensible means it will be made up of some material like rubber, okay, which have the, okay, the expanding and the contracting property. It will also affect the time period. Clear? And which in turn will also will vary the value of acceleration due to gravity. So that's why the string is taken massless and inextensible.